Welcome to SP Smart's NEET Direct program. Today we shall discuss the previous year questions answered in various competitive examinations from the chapter of Properties of Bulk Matter part 2nd. So let's start from question first. Two raindrops of same radius small r falling with terminal velocity v merge and form a bigger drop of radius capital R. The terminal velocity of the bigger drop is, that is, in other words, हमें terminal velocity का formula ये use करना है, this one, right? Over here, as we can see, the same material, they are passing through air. The both are made from water, so these two are constants. Viscosity is also constant. That is air's viscosity, G. This everything is constant. So we are left with this formula, right? Now for a smaller drop, this is a formula. For the larger drop, this is the formula as per the question. So take a ratio. So it's capital B by small v, capital R by small r whole square. So capital V is R by R whole square into small v. And let's check out. It is, yes, capital R square by small r square into small v. So this is there, capital R square by small r square into small v. So this is option B. So B option is the correct option for this problem. Okay, now let's move on to question second. As you can see in this problem, there is a water tank and water is filled up to a height of H capital, and there is a tiny hole over there at a depth capital D. You have to find the value of X. दूसरे शब्दों में, you are supposed to find the horizontal range of this water jet. Now I tell you a little simple trick. Doesn't it resemble the problem of a horizontal projectile motion? In horizontal projectile motion, the range is given by u times 2h by g, where u is the velocity, and that velocity here we say is the velocity of a flux, which is given by 2gh as per the Torricelli equation. Now make this substitution over there. But remember, these two h, they are having different values. For example, in case of the projectile motion, this h is height of the tower, and here it is exactly this thing. But as this water projectile is being launched from this height means capital H minus D. So instead of H, I should write H minus D. I'm teaching you how to convert projectile motion concept into the range of a water jet. And as per Torricelli's equation, this 2gh, here h is height from the top, and in this problem, as you can see, it is capital D. So here I'll write this. Now the trick becomes little more complicated. Here, instead of R, put X. I write X. Instead of U, you put 2gd square root. So this is what I do. Now instead of this 2h, you write h minus d. It's 2 times h minus d by capital G. Now simplify it further. Take everything inside one single square root. It now becomes something like that. These two get cancelled. This is now 2 into 2 becomes 4, and 4 is now h minus d, this one, and this capital D here, square root. Simplify it further, bring out 4, square root 2, so it's d times h minus d. This is the value of the range of this water jet. So 2 times, let's check out which question has this correct option, 2 times d capital H minus d. Well, I think this is there. Yes, it is C option, 2 square root of d into H minus d. It is 2 into d H minus d. So option C is the correct option for question second. All right. It is such a popular formula that you can even memorize this. This formula will help you to solve various other numerical problems, right? Okay, now let's move on to question third. What is filled to a cylindrical container at height of 3 meters? So this is the height of the container which has water filled. There is an orifice, means छोटा सा छेद है. Orifice means this small little hole. Uh, and the area of cross section, the ratio of cross section area of the orifice and the beaker means this area and this area. Small area by capital area. This is what I symbolically call it. If this area is A, this is capital A. This is 0.1. Then what is the square of the velocity of the liquid coming out from the orifice? Take G as 10. In short, this is a problem concerned with Bernoulli's principle, and P plus H rho G plus half rho V square is constant as per Bernoulli's principle. Now, H in this problem stands for this height. This height. First of all, I'll write pressure P. H means this minus this. So it's 3 meter minus 0.525 meters. This is H. Because it is in centimeter, I change this into meter. If I change this into meter, it becomes this. So this height means what I've written into rho, the density. Density of water, as you know, is 10 power 3 and G is taken as 10. So I've made substitutions for H rho G here, right? Plus, as you can see here, is half rho, again the density, which is 10 power 3 velocity square. This is the velocity with which the level is going down. I write it capital V square. This should be equal to pressure P, because as per Pascal's law, pressure is same. So P is there, but next this term happens to be 0. Why? Because now distance of this point with respect to itself is 0. This point with respect to itself has a height 0. So H rho G term becomes 0 plus half rho. Rho again 10 power 3 into velocity square. So it is small v square, because मैंने symbol रखे थे small v and capital V. Okay, this p gets cancelled as it's same on both sides. Now you simplify it further. So on simplifying it further, we get this term as 24750, and I push this on this side. It is now 500 into small v square minus capital V square. You bring it here, transfer the terms. You have difference of these two squared values as 49.5. Alright, you just consider this equation 1. Now from equation of continuity, this velocity into area. This is a velocity I'm putting up here at small orifice into area. It should be this into area. This is equation of continuity, V1A1 equal to V2A2. And here this V is having this value. Check it out. It is given small a by capital A is 0.1. So here small a by capital A is 0.1. So it's V into 0.1. That is V by 10 is small v. Alright. You put in 1. So instead of V square, you have V capital by 100 minus this as 49.5. Right, you simplified first. So on simplification, you get it as 99 by 100. V square is 49.5. You shift this thing on this side, and therefore it becomes V square as 49.5 into 200 by 99. You simplify it further, it becomes 50. So 50 meter per second whole square should be the answer. Now let's check out which option is 50. And here 50 option means option A. So finally I conclude that A is the correct option for this problem, right? So in this way, we have finished all the problems related with previous year questions taken from various competitive examination from the chapter of properties of bulk matter for the NEET direct program. And here question 1 has an option B as a correct option, question 2 has option C as a correct option, and question 3 has option A as a correct option. And that's all for today. God bless you all.